we will now move on towards understanding the derivative of trigonometric functions. So let's begin today's session. Okay, so just a moment, we'll start. Right, so I'm just referencing what we did in the last lecture. So worksheet 2, we had discussed the questions, doubts, okay. And then we were discussing about trigonometric functions and their derivatives. So we're talking about basics of trigonometry, right? Okay, so we were talking about sine and cos in the 4 quadrants. Very important aspect. So let me go through that once more. Then we will come to the derivatives of trigonometric functions. So this is session number 7 of basic calculus. So let's look at sin x and cos x for x being the set of general values. So once more, let's understand this. Okay. So this is about trigonometry in 4 quadrants. So ultimately what we had seen is that if you relate sine theta and cos theta in terms of components of a unit vector rotated through an angle theta, then we can understand it this way, that we are in the first quadrant. Theta is like this. This is cos theta. This is sine theta. But now if we switch over to the second quadrant, so here we are understanding cos theta and sine theta as the components of projections of a unit vector rotated through an angle theta. So this is a vector of magnitude 1. So you can even call it A cap like this. Okay. So this A cap is cos theta I cap plus sine theta j cap, where you can see that if theta is acute less than 90 degrees, then cos theta is also between 0 and 1, and sine theta is also between 0 and 1. Okay. But the moment we talk about theta being in the second quadrant, so theta is like this. So it's between 90 degrees and 180 degrees. We're in the second quadrant now. So now when we express this unit vector, you can see that
Sir,
so now
when
we express.
the graph will be in the first quadrant, so it will be between 0° and 90°. That graph.
Yeah, it's between 0 and 90, as you can see. Theta is between 0 and 90. It's in the first
So you
quadrant.
wrote, sir, 0 and 1.
Sorry, what will be between 0 and 1?
Sir, you wrote 0 and 1.
That is cos theta and sin theta. Theta is between 0 and 90. See, we've written this.
Okay.
Theta is between 0 and 90. Cos theta is between 0 and 1. Sin theta is between 0 and 1. Okay. So now when we are in the second quadrant, you can see that this cos theta will have to become a negative quantity, whereas sin theta is still a positive quantity. So our a cap, which is expressed as cos theta a cap plus sin theta j cap. So in this cos theta will become negative of cos alpha or negative of cos 180 minus theta. Whereas sin theta will be positive of sin alpha or positive of sin 180 minus theta. So this is the logic of the formula that we get in the second quadrant. So for example, if we are asking what is the value of cos 120 degrees, so immediately understand that cos 120 will be minus of cos 180 minus theta, or okay, so it will be minus of cos 60. So that will be minus half. Whereas suppose now we ask ourselves what is sine of 150. So you immediately understand that sine 150 will be positive of sine 180 minus 150. So that's positive of sine 30. So that will be half. Okay.
So
Yes.
in the second graph, like you have written a cap is equal, so that should be negative cos theta. I
No,
cap,
no,
right?
cos theta's value is negative. Okay, because theta is obtuse. Understand? So what
Okay,
tells us is that this thing that when theta is in this range between 90 and 180, automatically cos theta is becoming a negative quantity. It's minus of cos alpha. If I write it as minus cos theta here, I'll get a double negative sign. Then it will become positive. You understanding now?
yes, sir.
So the definition of cos theta is the x projection or the x component, and sin theta is the y component. Now the moment your theta is in that range between 90 and 180, your cos theta itself becomes a negative quantity, but sin theta remains a positive quantity. And the logic of that is because the vector is looking like this. When theta is obtuse, your vector is in the second quadrant. So obviously its x component is negative and its y component is positive. Okay. So here cos theta itself is a negative quantity, whereas sin theta itself is a positive quantity.
So can we write them, please?
Yeah, you can write this down.
Sir, what is alpha over here?
You can see what is alpha. It's in the diagram over here. It is the complement of theta. Alpha plus theta is 180. The same thing that we did in the last lecture. You can see alpha is that angle that is making with the negative x-axis, where theta is the angle which is anti-clockwise with respect to the x-axis. So always we define theta, when we are defining sine theta, cos theta, we define theta as the anti-clockwise angle with respect to positive x-axis.
Sir, anti-clockwise, after that, what you have wrote?
With respect to positive x-axis. Anti-clockwise angle with respect to positive x-axis. Angle with respect to positive x-axis. Right, so these two examples are clear to all of you. Cos 120 and like cos 120.
Sir, at the top, you have wrote for X, E general values.
Sorry,
Sir, at
general
the top,
values. So we are
X,
discussing
E
about
it is.
x belongs to. This symbol is belongs to.
Okay.
This x belongs to the set. It's mathematical language. So you don't need to write down everything in detail because I'll be sending you the notes. But make sure you understand how we got these set of formulae. That's cos of theta is minus cos alpha or minus cos 180 minus theta, whereas sine theta is positive of sine 180 minus theta when theta is in the second quadrant. So these are the formulae that we use for theta being in the second quadrant.
Sir, when we go further in this syllabus, do we have to draw graphs also?
Yeah, you have to know the graphs of sine and cos. That's correct.
So will we have to draw it also?
Yeah, I'll explain the graphs to you. Let's first understand the formulae of the four quadrants. Okay, now another thing that you should know is the relationship between radians and degrees. You should know how to interconvert. So
Sir,
for
I
example,
wasn't
I is equal to
finished
180.
writing.
sorry, what happened?
Sir, I wasn't finished writing.
Okay, as I said, you don't need to write everything in detail. Just write down the examples which are more important. I'll send you the notes so you can pair your notes yourself later. Okay, so one more thing you should know here is how to convert radians to degrees and degrees to radians. So remember, pi radians is equal to 180 degrees. Okay. So x degrees becomes x by 180 into pi radians. Okay. Or if we take y in radians, that becomes in degrees. Okay. So for example, if I ask you 2 pi by 3 in degrees, so how much that is? So you'll understand that it's 2 pi by 3 upon pi into 180. So it is 120 degrees. Okay. At the
Sir,
same
this
time, if
is
I
the
ask,
formula.
sorry,
Sir, this is the formula.
yes, I explained to you radians and degrees last time only that a half circle or a semicircle is equivalent to pi radians, because a full circle is 2 pi radians. So I hope you people are in the habit of revising the lecture notes. So,
Yes, sir.
yeah. So for example, now if I ask you convert 135 degrees into radians, the answer to that will be 135 degrees is equal to 135 by 180 into pi. So you can see that that will become 3 pi by 4. So therefore, before we come to this example, this formula that we have just written for second quadrant, we can convert it to a formula for radians also. Okay. So we've written cos of theta is minus cos 180 degrees minus theta, and sine of theta is positive of sine 180 minus theta. This is when theta is in degrees. Similarly, if you want to express it in radians, become cos theta is equal to minus cos pi minus theta, and sine theta is positive of sine pi minus theta, where theta is in radians. So for example, what is cos of 3 pi by 4? So we use this formula that cos of 3 pi by 4 is minus of cos pi minus 3 pi by 4, which is minus cos pi by 4, which becomes minus 1 by 2. Because basically pi by 4 is 45 degrees. 3 pi by 4 is 135 degrees. So the second quadrant formula for sine and cos, you should know it regardless of whether you are given the value of theta in radians or in degrees. You should know how to interconvert.
Sir, how you have wrote that pi upon 4?
I have told you the formula beta for this. See, conversion of radians to degrees. So pi by 4 radians is how much? Pi is equal to 180 degrees, na? So it's 180 by 4, na? In degrees.
Okay, sir, understand.
So just remember this basic concept that pi radians is equivalent to 180 degrees. Rest is unitary method.
Okay, sir.
Okay, now let's come to third and fourth quadrant. So theta is in the third quadrant. That means the angle by which this is rotated with respect to the x-axis, that will become something greater than 180 but less than 270. This means that theta is greater than 180 degrees but less than 270 degrees. So now you can see from this clearly that when you drop the perpendicular on the x-axis, the x component cos theta will be negative because it's falling on the negative x-axis, and the y component, this one, will also be negative. So that's why in the third quadrant both sine and cos are negative. And now if I take this angle as alpha, okay, so you can see that theta is equal to 180 plus alpha, okay, or alpha is equal to theta minus 180 degrees therefore. So from this you can see that since my a cap is cos theta I cap plus sin theta j cap. But here this is also negative. This is also negative. So when we are finding out the value of this cos theta and sin theta, cos theta will become negative of cos alpha. That is negative of cos. Now alpha this time is what? It is theta minus 180. Okay, because it's this angle here. Theta is equal to 180 plus alpha. So alpha is theta minus 180. And sin theta becomes minus sin alpha. So that is minus of sin theta minus 180 degrees. So these become our formula for third quadrant. Okay. When we express theta in degrees. Same way, if we express theta in radians, this will be cos theta will be expressed as minus of cos theta minus pi, and sin theta will be expressed as minus of sin theta minus pi. This is where theta is expressed in radians. So these are the formulae for the third quadrant when theta is expressed either in degrees or radians. Now, likewise, we'll complete the discussion for the fourth quadrant, then we'll do a couple of examples. So for fourth quadrant, what is happening is that we should have rotated our vector, unit vector, in such a way that the angle by which we have rotated is bringing it like this to the fourth quadrant. So this angle is our theta. So theta in the fourth quadrant now means that theta is greater than 270 degrees and less than 360 degrees. So now if I treat this angle as alpha, so I can see that theta is equal to 360 minus alpha, or alpha is equal to 360 minus theta. So now when I express my unit vector in component form, you can see that this time the x component, which is cos theta, is positive, whereas this time the y component, which is sin theta, is negative. So my vector will have an x component which is now positive, but a y component which is now negative. So using this, you can see that the value of cos theta will become plus of cos alpha, because cos is positive. Or we can say cos theta is positive of cos 360 minus theta, whereas sin theta is the one which is negative. It's minus of sin alpha. So sin theta will become minus sin 360 minus theta. So this becomes my fourth quadrant formula, where theta is in degrees. Okay. Similarly, if we want to express theta in radians, it will become cos theta is positive of cos 2 pi minus theta, because 2 pi is equivalent to 360 degrees, and sin theta is negative of sin 2 pi minus theta. This is when we are expressing theta in radians. So these two are the diagrams explaining the situation, that why sine and cos are both negative in in third quadrant, whereas cos is positive and sine is negative in fourth quadrant, and how to relate them. Okay, so ultimately, which is the important set of formulae? This set of formulae here and this set of formulae here, and they are rewritten in radian form, so that's nothing very difficult. So whenever we have an angle theta which is in this range, okay, that it is between 180 and 270, we use these two formulae. Similarly, whenever we have a theta in this range, that it's between 270 and 360, then we have to use these two formulae. Okay. Now, as you can see, you don't need to memorize these formulae anymore, because you understand them by just visualizing how the vector's components look when you rotate it by that kind of an angle. Right? So just make a note of this, and I'll explain with few more examples. So this time we'll take some mixed examples so that you can directly understand.
Sir, it means when the graph is in first quadrant, then only the sine theta is positive, right?
But sine theta is also positive in second quadrant. So sine is positive in two quadrants, first and second. Cos is positive in two quadrants, first and fourth. Right?
Yes, sir.
So you
But
must
in
have
second quadrant, so sine theta lies in this y-axis, na? Sorry,
positive y-axis.
minus x.
See, second quadrant. Where did it go? Second quadrant was here. No? See, second quadrant sine is positive. You can see.
Okay. Cos is negative.
So you have to just visualize it this way, na? That just visualize the vector in the second quadrant. So you can immediately see your y component is positive. So sine theta is positive, but your x component is negative. Similarly, visualize a vector in the third quadrant. So you'll immediately, once you visualize it, you'll understand that both are negative. So you don't have to memorize it as a formula. You can just visualize and recall.
So
Yes.
I have a doubt in what you have written.
Yeah.
In the fourth quadrant, you have written minus sine 360 minus theta. But 360 minus theta will be minus sine theta. So it will be minus of minus
No,
sine
no, no.
theta.
360 minus theta is not minus beta. 360 minus theta will be an acute angle here. Because remember, theta is between 270 and 360. Na? So for example, if you write your theta as 300 degrees, right? So 300 comes in that range.
Yes.
You understanding now? So in that formula, what will sine 300 become? Sine 300 on the left hand side will be on the right hand side minus of sine 60.
Yes.
So now you understood now why it comes out to be minus root 3 by 2.
Okay. Actually, I was going by the formula like in maths there. So that's why.
It's the same formula in maths beta. So that is why, see, now 360 is equivalent to 0. No? So that is why we can also write it as sine 360 minus theta is the same thing as sine of minus theta.
Yeah, so sine of minus theta will be minus sine
Minus
theta.
sine
No?
theta. So that's the thing. No?
So, but there is another minus sign. So
No,
minus.
see, ऐसा है, देखो, you are confusing the theta with the alpha here. See, this theta which we are writing as 360 minus alpha, correct? Yeah, no? So this can also be written as minus alpha. You getting my point, beta?
Yes, yes.
So sine theta is the same thing as sine of 360 minus alpha, which is the same thing as sine of minus alpha. Okay. Now see, according to this formula, what is sine of 360 minus alpha? It is minus sine alpha. It's minus sine alpha, no? And that is why sine of minus alpha is minus sine. Okay.
Okay, sir.
So understand this with a practical example. Okay, so suppose I take my theta as 315 degrees. Okay. So if I take theta as 315 degrees, so I can express theta as 360 minus 45 degrees. Okay. And trigonometrically, 360 is equivalent to 0. No? So that's the same thing as minus 45 degrees. Got it, no?
Yes, sir.
So we will say sine of theta, which we can write as sine of 315, is equal to sine of 360 minus 45. Okay. So according to this formula, this is equal to how much? It is minus of sine 45. Okay. But according to this one, it's equal to how much? It's sine of minus 45. So that's why sine of minus 45 we say is minus sine 45. So it's minus 1 by 3.
Yes.
Okay, so we'll do some examples. Okay, we'll come back to this. Just note down the diagram and the formula first. Then, so this is a little confusing in the beginning, but as you get used to doing some examples, it becomes clear.
Sir, I have noted this down. Can you go just a bit up?
Yeah, I'll go just a bit up. Just a minute. Before that, yeah, Rishita, beta, you had a doubt that theta is the convention for alpha. No, like see, the convention that we are using now, Rishita, is like this, that when we are in the second quadrant, okay, we reference the angle with respect to 180. So it's less than 180, no, but greater than 90. So we'll write it as 180 minus something. So if theta is in second quadrant, we'll write theta as 180 minus some acute angle. Okay. If we are in third quadrant, then theta is becoming greater than 180 but less than 270. So we'll write theta as 180 plus some acute angle. Okay, and if we are in fourth quadrant, then it's less than 360 but greater than 270. So we'll express theta as 360 minus
360
alpha.
minus alpha. Okay. Thank
So when
you,
we
sir.
express it this, yeah, beta. Sorry, what were you saying?
I said thank you.
Oh, okay. Now the thing is, the advantage of expressing this way is that we don't have to interchange sine and cos. Like, see, if I express, for example, 240 degrees, I can express it as 180 plus 60. Okay. So then the advantage of expressing it this way is that I'll say that, okay, sine of 240. Now in third quadrant, sine is negative, is the same thing as minus sine 60. So in my formula, there's no complication. Sine remains sine. So it's minus root 3 by 2. But I can notice I can also express 240 degrees as 270 minus 30. I can write like this also, no?
Yes, sir.
But if I reference it this way, my formula is a little bit more complicated. I'll have to express sine 240 as minus cos 30. So it will give me the same value minus root 3 by 2. But because I have referenced it to 270 instead of 180, I have to interchange sine and cos. Okay.
Yes,
so
sir.
which is why I've avoided giving you those set of formulae here because they are confusing. It is better that you reference to 180 and 360. Understood? No, you
Okay, sir.
reference it to the horizontal line, the x-axis, so that sine remains sine, cos remains cos. All you have to do is you have to understand where it's positive and where it's negative, and for that just the visualization is enough.
Okay, sir. Thank you. I understood.
Okay, very good, beta.
Sir, can you stop the screen in middle somewhere?
Where here?
No, sir.
Further down.
Yes, sir.
This examples you want.
Yes, sir. Yes, sir. Yes, sir. 2
Yeah,
minutes.
okay, just a second. Yeah, so we'll do some more examples next. Just note this down first.
Done, sir. Thank you.
Okay, so this is written down now, you.
Yes, sir. Done.
Yes, sir.
Done now, beta? Okay, okay. Achha, so now see. Now what I'll tell you is even more strange, that I'll say forget all the formulae. Okay, whenever we want to find sine or cos of any angle, just do it in terms of a diagram. Just visualize it as a diagram. So for example, if I randomly tell you find out, let's say sine of let's say 217 degrees. Okay. So I'll say don't apply any formula, first quadrant, third quadrant, nothing like that. Just think of it, okay, that what is the meaning of an angle of 217 degrees? We all understand that it's an anti-clockwise rotation by 217 degrees, right?
Yes,
Yes,
sir.
sir.
So logically what we are doing, we are taking a unit vector a cap and we are rotating it by यहाँ से लेके 90 फिर 180 फिर 180 से थोड़ा ज़्यादा हो. So obviously it's somewhere here. So it's,
Yes.
so if this whole angle is 270 degrees and this is a unit vector, okay, so its magnitude is 1. Now just apply your normal trigonometry. So drop a perpendicular here, okay, and drop a perpendicular here. So now see, think of this triangle.
217 degrees, right?
Sorry, 270. Yeah, my mistake. 270 would have brought it to the negative y-axis. Yeah, 217 degrees. Okay. So that's our theta, right? Okay. So now see, this triangle that I'm shading, it's a right angle triangle, you can see. Okay.
Yes, sir.
तो उसमें अगर ये base है और ये perpendicular है, then which is the angle that I'm referencing? I'm referencing this angle. Right?
Yes, sir.
Yes,
So
sir.
this is, let's say, alpha. Now tell me how much is alpha by calculation here?
37 degrees.
Yes, it's 37 degrees. No, because up to here is 180. So alpha is obviously how much? Alpha is 217 minus 180. No? So it's 37 degrees. Okay. So now I'll just draw that triangle separately. That triangle is which one? It's our 37, 53, 90 kind of angle triangle, right?
Yes, sir.
Is this triangle? Okay. So if this one has a has a hypotenuse equal to 1, how much should its base be? Base upon hypotenuse should be cos 37. So that's 4 by 5. Okay. So base will directly become how much? 4 by 5. Because hypotenuse is equal to 1. Right?
Yes, sir.
And
Yes, sir.
perpendicular upon hypotenuse should be how much? Sine 37. So वो कितना होता है? 3 by 5. This I
3
have to
by
remember.
5.
Okay, these values I have to remember. So the perpendicular is directly equal to how much? 3 by 5. Okay. So now let us come back to this unit vector. So this unit vector should be how much? It should have, now see, the base is lying along which direction? Negative x-axis. Okay. So it should be minus 4 by 5 I cap. Okay. And the perpendicular is lying in which direction? The negative y-axis. Okay. So this is its sine theta. No? And this is its cos theta. No? So they should come with sine, no? With the algebraic sign. So what should the algebraic sign be? Negative for both of them. Okay. So what this is telling me that if alpha is this much, it's automatically telling me that cos 217 is minus 4 by 5 and sine of 217 is minus 3 by 5. Okay. So this is the way of doing it without applying any formula at all, just by visualization. Okay. Whereas if you went by formula method, what you would do, you would say, okay, theta is 217. So first thing, that means that theta is greater than 180, less than 270. So I have to apply the third quadrant formula. So notice what is the formula in the third quadrant? That sine theta is minus of sine theta minus 180 degrees, and cos theta is minus of cos theta minus 180 degrees. So I'll apply this to this example. So sine of 217 degrees will be minus of sine 217 minus 180. Okay, so that is minus of sine 37. So that is minus 3 by 5. And see, we got that just visually over here. And similarly, cos 217 will become minus of cos this. So that's
So
minus
4
of
upon
cos.
5 and 3 upon 5 are the values.
हाँ, वो आपको याद रखना है बेटा. Remember I told you the 3 standard type of right angle triangles last time?
Yes, sir.
30, 60,
Yes,
90, then
sir.
the isosceles one, then 37. Those you have to remember. Okay, those standard values you have to remember. All right, so this example is clear, na? So how do we get this? By just rotating this by that angle and then using our normal method of trigonometry. But understanding that there is sign convention involved. Okay? So if the component is on the negative x side, our cos theta will have to come with a minus sign. If the component is on the negative y side, then our sine theta will have to come with a negative sign. Okay. So note this down and try out this next example. Five pi by 3. Okay.
Sir,
Yes.
sir, one doubt, sir.
Yeah, tell me.
Sir, in that triangle, sir, sir, you assume h to be 1.
Sorry, what tends to be 1?
Sir, you wrote na h is equal to 1.
Hypotenuse is equal to 1. Yeah, because it's a
Yes.
unit vector. Na?
Okay, sir, but its value would be 5, right?
नहीं. वो ratio 3 by 5 है बेटा. Okay. So if h is equal to 1, then perpendicular कितना हो जाएगा? It will be 0.8, no?
Yes, sir.
Oh, sorry, 0.6, and the base will be 0.8 like that. No? So the
Yes.
ratio is 3:5 and 4:5 like that. But that doesn't mean that the triangle has to have sides of 3, 4, and 5. Na? It can be 3x, 4x, and 5x, where x is anything.
Yes, sir.
Yeah, Rishita is fine. So cos 5 pi by 3 you got correct. I have actually asked both the things. Sine 5 pi by 3 also and cos. So both of them are
So
questions.
sine 5 pi by 3 in degrees
Ah.
or the value?
So tell me sine 5 pi by 3, how much it will come out to be?
Sir,
So minus root 3 by 2.
minus root 3 by 2.
Very good. So 5 pi by 3 you can convert if you like first of all. So it is 5 by 3 into 180.
So
Sir, 300.
So 300 degrees. Okay. So that means like if you just do it by visualization. Now initially you might think that okay, all this is taking a lot of time, but yeah, I'm also drawing the diagram.
Fourth quadrant.
Very detailed manner. You need not do that, but you'll understand that. So if this angle is 300, so immediately you can see that this angle here is 60. Okay. So when you drop a perpendicular here, you can see that it's that very simple triangle. Is that 60, 30, 90 triangle. So you can see that our cos theta will just become positive of cos 60. So that is half. Whereas this side, our sine theta, so sine theta will become negative of sine 60. So it's minus of root 3 by 2. So you have the formula directly for that. That sine of 5 pi by 3 is equal to minus root 3 by 2. And cos of
Sir,
5, yes.
sir, instead of this, means I wrote 270 plus 30 and interchange it into cost.
You can also do that, but the only danger in that, don't get confused by interchanging. That's all I'm saying. Like, if you're comfortable with that set of formula, you can do that also. Instead, so in my diagram, basically what I've done is I've used this concept that 300 can be expressed as 360 minus 60. Okay, and therefore the formula are reference to this, that cos of 300 is cos of 360 minus 60. So it is plus of cos 60. Okay, and sine of 300 is sine of 360 minus 60. So that is minus of sine 60. Okay, but you can also express 300 this way, that 300 is 270 plus 30. Okay, so cos of 270 plus 30 will become plus of sine 30, and sine of 270 plus 30 will become minus sine, minus cos. And the logic for that also you can see in this triangle. Instead of referencing this angle, if you just reference this angle is the same as this, and this is 30. So you can see that this and this is changing. Okay, so this is becoming same thing as cos 30, and this is becoming the same thing as this is becoming sine 30. I mistake. So this is the same thing as sine 30, and this is the same thing as minus cos 30. But all I'm saying is like you can just take a simplistic approach where you always remember to reference with respect to 180 or 360, because then you're always referencing with respect to the x-axis. So your sine and cos don't interchange in your formula. Okay. And yes, one more thing you can do is you can get used to radian notation so that you don't have to convert. So you can come to a stage where you can just understand in terms of radians only that an angle of this much.
Sir,
Yes.
sir,
5 pi by 3 will be an angle such that this angle here is pi by 3, because the total is this. So once you do that, it will become even easier. So you can see that cos theta here will become plus of cos pi by 3, and you learn to recognize that plus cos pi by 3 is half, and sine of theta here will become minus sine
sir,
pi by 3. Yes.
sir, in that example where you have taken 217 degrees, if we write it with reference to 270 degrees, then it will be 53 degrees, right?
Yes, yes. So
So then
270
we have
अगर
to
ऐसा लिखूंगा मैं, ये कितना हो जाएगा? 270 minus 53 degrees, है ना?
53. So then
So-
too we have to use that three right angle triangles wala concept, right?
That concept or the formula will become like this, that cos of 217 will become minus sine 53, and sine of 217 will become minus cos 53, because the triangle will be looking like this.
Right?
So now you are seeing that this angle is 217, but you are referencing this angle as 53 now. So you'll have to talk about this triangle, but from that you will get the same result. Got it now? This clear?
Yes, sir. But we won't get any other random values, right? Such as 43 or something.
Like directly you will get values which are related to, like, where the reference values you have to remember are those three triangles I told you: 30, 60, 90 triangle, 37, 53, 90 triangle, and 45, 45, 90 triangle, which is the easiest. Okay, people. So I think with this you should be able to handle any values of cos theta and sine theta. Okay.
So can you do the slide a bit above?
Yeah.
Sir,
Yeah, better.
for physics, do we need to know how to interconvert sine and cos?
No, the interchangeable ones you don't need to know. Okay.
Okay.
These ones, 270 reference.
Yes, sir. Like how to convert the cos into sine. I only know up till 90 degrees.
Yeah.
Formula.
That's fine, beta. Just know the values up to 90 degrees, and then once you're going into 4 quadrants, just use the reference with respect to 180 and 360 like I told you.
Okay, okay. Thank you, sir.
So this one I wrote. Can you put a bit down?
Below
Yes, sir.
this one?
Yes, sir. Just a bit.
Okay.
Sir, I had a doubt.
Yeah, beta.
Sir, it's not related to the question, but like for calculus, like the book we got from
Sorry?
the coach. For calculus, like the integration and derivation, for the book we got from the coaching, we can do like examples or like questions from there, or do we need to like study calculus in depth now?
Beta, come again. I didn't follow your question. You are talking about some reference book or?
Yeah, sir. Like for calculus, should we just like study like from the book we've gotten from the center?
Yeah, just from the module bit. Okay.
And like we don't need to like.
No, for calculus, I would
follow.
not recommend you to follow any other book. When we finish calculus and when we start kinematics, then I will
Yes,
give you a
sir.
list of reference books.
Okay, sir.
Okay. But for vectors and calculus, just follow the module. Once we have you started Newton's laws yet, or you're still going on with vectors?
So
So we are
vectors.
still doing
Sir,
vectors.
vectors only till now.
Yes, sir.
So fine. So just wait till vectors and calculus is finished. Then we'll give you an official list of books for reference in physics. Once we start the next set of chapters, one will be Newton's laws of motion for Sir's track, and my track will be doing kinematics.
Yes.
Done, sir.
Okay. So now that we've understood this sine and cos in 4 quadrants, now we convert this to a graph. Okay. So if we plot the graph of sine x versus x. So now x is not the quadrant, okay, or the coordinate. X is the angle itself. And we are plotting the graph of y is equal to sine x as a function. So we can see that in the first quadrant, as x goes from 0 to 90, sine x goes from 0 to 1. But now we also understand in second quadrant, you will remember sine was positive. So it comes back to 0 by the time you are at 180. So one of the formulae we had seen earlier today, that sine of 180 minus alpha is the same as sine alpha. You can understand this over here. Because if this distance is alpha, so this angle over here is how much? It is 180 minus alpha. And you can see the value of sine is same for both of them. So you immediately have the formula that sine of 180 minus alpha is sine alpha. So for example, sine of 150 degrees is equal to sine of 30 degrees is equal to half. You can see that in that graph. Okay. Now as we go beyond 180, as we've seen in the diagram earlier, that sine becomes negative in the third quadrant. And by the time you reach 270, it becomes minus 1. And then fourth quadrant also sine is negative. By the time we come to 360, it comes back to 0. Okay. So the sine graph is basically like a wave like this. It will keep going even beyond 360. Now it will repeat itself. So now the other formula you can see is the third quadrant formula, that if this angle is, this is again alpha, then this value here will become 180 plus alpha. But you can see the value of sine is becoming negative. So you have a formula that sine of 180 plus alpha is minus sine alpha. An example of that we just saw earlier today, that sine of 180 plus 37 is minus sine 37, or basically 217. Okay. So sine of 217 was minus sine 37. So you can see that visually in the graph how that is happening. Okay. If this angle is 37, okay, and I select something beyond 180 by 37 degrees, you can see that this value here and this value here are symmetric. This is 3 by 5, this is minus 3 by 5. Because this distance and this distance on the graph are symmetric. So this angle is becoming 217 degrees. Okay. And then there'll be another value at which it repeats itself, and that will be this one. So this time this is 37. So this angle will be 360 minus 37. So that is how much? 323 degrees. So we have one more formula, that sine of 360 minus alpha is minus sine alpha. So for example, sine of 315 degrees is minus sine 45 degrees, minus 1/8. Or like the one I've taken above, sine of 323 degrees is minus sine 37. So that's minus 3/5. So that symmetry and that alternate plus minus thing you can see in the graph of the sine wave also. Okay, so likewise now we reference the graph of cos x.
Sir, can you show the bar graph for 1 minute?
Yeah.
Before this, we did that.
Yes, sir, completed.
Sir, there is a lot of disturbance because someone's
Sir, are you
mic
there?
is on.
Siddhant, please mute your mic.
Okay, so let's look at the graph of cos x. So as you know, cos has a graph where cos of 0 is 1. And as x increases from 1 to 90 degrees, cos x decreases to 0. second quadrant cos becomes negative. So it goes to -1 as x goes to 180 degrees. So as you can see, for example, cos 30 okay, so if we take a value of 30, let's say it's somewhere here. So the value is √3/2. But if you take a value of 180 minus 30, so that's 150 degrees. So the value of the cos function becomes exactly negative of that value over there. Here becomes minus √3/2. So through this example, you can see the relationship that if this is alpha over here, then this value is alpha. So this angle is how much? It's 180 minus alpha. So we have the formula cos of 180 minus alpha is minus cos alpha. And hence the example that cos of 150 is minus cos 30, which is minus √3/2.
Sir, between 152 and 180, you have wrote what in purple?
It's supposed to be alpha, but it's looking like a reverse alpha. So this interval is alpha, so this interval is alpha. Understood now? Right?
Yes,
sir.
sir.
So in this particular case, alpha is 30. In this example, alpha is 30. Okay. Now you can also see what happens in the third quadrant. It's symmetrical to the second quadrant, but like a mirror image. So now if I take another interval of alpha of 30 over here, the value I'll reach here is how much? It will be 180 plus alpha. So in this case, that will be how much? That will be 210. Correct. So the value will be the same here. So we have the additional formula that cos of 180 plus alpha is actually the same thing as minus cos alpha, which by the same way is the same thing as cos of 180 minus alpha. So ultimately, cos of 210 has the same value of cos 150, which is nothing but minus cos 30 or minus √3/2. So you see that symmetry here. You can visualize this symmetry like this, that going back to the 4-quadrant diagram, okay, this is the situation in which your angle is, let's say, 210. Whereas this would be a situation where your angle would be 180. But in both cases, this is the same. Because this angle is equal to this angle, which is 30. So you can see the formula, how it's working out from here and there. So hence we are getting that cos 180 is the same thing as cos of 210. So 150 is the same thing as cos of 210, which is the same thing as minus cos 30. So this one should be 150. Okay. And now finally coming to the 4th quadrant. So completing the cos graph. So now in the 4th quadrant, if you see, now if I again reference with respect to 360, so my angle should be 360 minus alpha. So this angle here will have the same value as alpha. I mean, the cos will have the same value as. So for fourth quadrant, we have that formula that cos of 360 minus alpha is the same thing as cos alpha, positive of cos alpha. So for example, cos of 330 degrees will be the same as cos 30 degrees, which will be positive of root 3 by 2. So this is your second quadrant formula. This is your third quadrant formula. And this is your fourth quadrant formula. And you can see how the symmetry is working out in the graph of cos also. So cos is also like a wave-shaped graph. Keeps going up and down like this. Okay. But the difference is that it starts from 1. Starts from 1 at theta equal to 0. And this is 360 and then it repeats itself.
So,
Yes.
as you have written, like the upper part is second quadrant and the lower part is third quadrant. But like the upper part should be first quadrant and the lower part should be second quadrant, right?
That is just the formula, beta. Actually, this formula is applying to these angles here between 90 and 180. See, no?
Okay, sir.
So this is actually applying to this here. And this one is applying to this one here. So it's third quadrant. And this one is applying to this one here. So it's fourth quadrant. And first quadrant, we don't need to write any formula because it's just the values, right? Okay, so we will just keep this graph in general in mind. Okay? Because in some future chapters like oscillations and waves and all that, we will need to reference sine and cos graph a lot. Okay, and wherever we need to reference again in future, I will give you a basic recap of it, so don't worry. But the more you are familiar with these from the beginning, the better it is. Okay. Now we will talk about derivative of these functions, which we have done before also, but once more we'll understand it from slope of tangent point of view. So derivative or instantaneous rate of change of trigonometric functions. So at a later stage, I will introduce you to the other trigonometric functions also, like tan, cosec, sec, cot, and all that. But right now we'll concentrate on sine and cos. So as we know that the basic formulae are that differentiation of sine x is equal to cos x. Okay. That's one formula, and the other formula is that differentiation of cos x is equal to sine x. Oh, sorry, is equal to minus sine x. Okay, so remember the cos comes with a negative sign when we differentiate it. The sine doesn't come with a negative sign. So you have to remember these two formulae. Okay. Now, for example, we want to find the slope of tangent for the graph of y is equal to sine x. Okay, at the point x is equal to, let's say, 30 degrees. Okay, then let's take a point in the second quadrant. So x is equal to, let's say, 120 degrees. Let's take a point in the third quadrant. X is equal to 240 degrees. And let's find a slope of the tangent in each. Okay. So this is where you have to know your trigonometry in 4 quadrants. Okay. So when we start this question, the first thing is, of course, we'll find dy by dx. So that is differentiation of sine x. So for that, we just refer to the formula. We know that by formula, the differentiation of sine x is cos x. Now we come to slope of tangent at each of these points. So the first part, what we mean by slope of tangent at a point is nothing but the value of dy by dx at that point. Now dy by dx is itself how much it's cos. So this will become cos 30, and cos 30 we all know is root 3 by 2. So that is the value of the slope of tangent at the point. So this is the slope of tangent for the graph of y equal to sine x at the point x equal to 30 degrees. So likewise, now tell me how much will be the second and third part. So I'll just minimize this a little, take down the formula, though I think we have discussed this formula once before also, when we were going through the formula of differentiation early on. Okay. So just note down this first part and tell me what is the answer to the second and third part. Try and figure out the answer and send it to me on the text message. Yes, you have to learn the trigonometric table values. So for that only, I told you that visualization of the 3 triangles is easiest. 30, 60, 90 triangle. Remember what is the visualization? It is this. So immediately you can see that cos 30 is equal to sine 60 is equal to root 3 by 2. So you don't need to memorize any table. Sine 30 is equal to cos 60 is equal to half. Okay, this one, then the 3, 4, 5 triangle, 37, 53, 90. Just these two, and obviously the isosceles one is very simple to remember. So instead of a long table and all that, you just remember these 2 triangles. The isosceles one is very obvious, so you don't need to memorize it separately. And then just remember the concept of trigonometry in 4 quadrants, like I told you. How to just visualize how your angle is rotating, where it is falling, second quadrant, third quadrant, etc., and which one is positive, which one is negative in each quadrant. Yeah.
So why did you take cos 30 rather than sine 30?
Because we are finding the value of dy by dx ना बेटा.
So
Sine 30 मुझे क्या देगा, मुझे y कोऑर्डिनेट देगा ना at the point 30 degrees, पर मुझे y कोऑर्डिनेट नहीं चाहिए, मुझे dy by dx का वैल्यू चाहिए ना, स्लोप ऑफ टेंजेंट चाहिए ना.
so उसके लिए हमको cos लेना पड़ेगा.
Yes, so what is dy by dx? It is cos x, no, that we have written earlier. Above
Yes.
c we have written dy by dx is cos x.
Yes.
So now what is the slope of the tangent at any particular point? It is the value of dy by dx at that point of x.
At that point.
So when x is equal to 30 degrees, what is the value of dy by dx? It's cos 30. So what that means is if I draw tangent to the graph at that point, its slope will be root 3 by 2.
Okay.
Okay. So when I draw the graph, this will become even more clear.
Sir, can you please not change this slide? I'm actually writing this.
Sorry, can I?
Please don't move this slide away.
Yeah, I'm waiting for you people to send me the answers also for second and third part. Write this down and send me the answers. Yeah, very good. Sanvi, Saad, correct.
So for second is also the same, no, cos 120.
Yeah, you will have to use that only. Rishita, correct. Manas, correct. Both parts. Swayam, correct. Very good. Sanvi, correct. Saad, correct. Ayan, correct. Rishita, correct for third part also. Good.
I have written the message of written the answer of third one. It is correct.
Okay, so very good. More people have sent me the answers. Piyu, Sakshi, correct. Very good. Manav. Okay, so I'm putting up the answers finally. Okay, then we will come to the visualization of this also. So dy by dx second part at x equal to 120 degrees will be cos of 120. Okay. Now for cos 120, you again either just remember the formula or you visualize it. Okay, so when you're at 120, basically somewhere here. So this angle you can see is 60. So cos theta will become minus cos 60 and sine theta will be plus sine 60. But we don't really need this. We just need the cos one. So cos 120 is minus cos 60. So that's minus half, or you can write it as minus 0.5. So that's your slope of tangent. This is only your this or this whatever is the slope of tangent at the point x equal to 120 degrees. Okay. And likewise, that's cos of 240. So 240 you will again visualize is 180 plus 60. So now we are in the third quadrant. So when this is 240, you can see that this angle here is 60. So cos 240 should also be minus cos.
Minus half, sir.
So this should also be minus. Okay. So this is also minus cos.
Sir, I have done the other way, 270 minus 30.
Then it will become sine minus sine 30.
Yes, sir. Because 90 to 70.
Yeah, they
is into
interchange sine and cos. So whichever way you, whether you do it by formula, whether you interchange sine cos or reference it to 180 and 360 like I have explained here, or you just draw a diagram like I've done on the left hand side, that's up to you. But you should just develop a method of calculating this correctly. Okay. Now you notice something interesting, that both these slopes that I'm getting are same. So it seems like there must be some kind of symmetry in the graph. Why this is happening? Yes, Piyu.
Sir, please can you explain this third one once again?
Third one में देखो हम क्या कर रहे हैं? We are finding the value of dy by dx at 240 ना. So dy by dx is what? Cos x. So cos 240 निकालना है. So come to the left hand side diagram. I'm rotating by 240. So that's how much? That's 180 plus 60 na. This angle here will be 60.
Okay, sir. Then.
So got it na. So now cos is on the negative side. Sine is also on the negative side. So you can see now, cos 240 will become the same thing as minus cos 60. Just a moment.
Sir. Okay, understood. Thank you, sir.
So just, just practice this out a couple of times at home, and like when you're revising today's lecture, just all the values that I have done on the board now, just do them on a fresh piece of paper yourself without referencing my notes. Try it out yourself. Okay. You will get it with bit of practice. It's nothing else. Okay. Now the slope of tangents, we have got the values, but what actually they mean? Let's try to understand that. So what we had started with, the graph of the function y equal to sine x. This was our original function. And then we were looking at the slope of the tangent dy by dx and the slope of tangent, that is the value of dy by dx at all these points, 30, 120, 240, etc. Okay. So let's visualize what this means geometrically. So which is the function whose slope we are trying to find out, or slope of tangent we are trying to find out? That is this function. So which is the graph we'll draw? We'll draw the graph of y is equal to sine x. Okay, so that graph we just saw, basically cyclically repeating graph like this. So now in this is 90, this is 180, this is 270, right, this is 360, this is -1, this is 1. Now notice, what can I say about the slope of tangent for any acute angle between 0 and 90? You can see it's a positive slope because y is increasing.
Yes.
So for example, at the point 30, you can see when we took the point 30 and drew a tangent at this point, this would have what kind of slope? It would have a positive slope. So in fact, what was this slope? We saw this slope was equal to
3 by 2.
Root 3 by 2. You know? So it's positive of root 3 by 2. But similarly, when we are talking about 120, now where is 120 located? 120 is somewhere here. Okay. So naturally, you can see it has a negative slope. So at this point, when I draw this tangent, that line has a slope of minus half or minus 0.5. Okay. And if you see something carefully, 240 is somewhere here. So not only it's having a negative slope, but in fact, this line is actually parallel to this one. These two are parallel because both of them are having a slope of how much? Minus half. So why they are parallel? That is also to do with the symmetry of the sine graph. Okay. Let me try and plot the symmetry of the sine graph in a better way. So let's concentrate on these 2 points now. 240 and 120. Okay. So the relationship between these 2 points is that they're equidistant on either side of 180 line. ये 180 plus 60 है और ये 180 minus 60. So the graph, see, it has that interesting aspect that यहाँ पे if I draw a tangent, the kind of line I'll get, and यहाँ पे if I draw tangent, the kind of line I get, they're actually parallel to each other. So this tangent 1, let's say, okay, and this tangent 2, they are actually parallel lines, and both are having a slope of minus half each. So that's why it should not come as a surprise that we got the same value of slope of tangent. So the interesting thing over here is that tangent 1, which is the tangent at x equal to 120 degrees, okay, and tangent 2, which is the tangent at x equal to 180 plus 60, so 240 degrees, are parallel lines. Because both have the same slope equal to minus half. They're parallel to each other. And that is part of the symmetry of the graph, because this interval is also 60 and this interval is also 60. So that 180 is like a symmetry point where the graph inverts. On either side of it, if I go same distance and draw a tangent, they are parallel lines. So this is the geometrical interpretation of the above results.
Sir, if it's parallel, then what we can do with it? Means any benefit or something?
Sorry, come again, beta. If it's parallel, then what?
What we can do with it? It is any benefit of
it has the same rate of change, no? So for example, later when we come to kinematics, okay, if this is some kind of oscillation and the y-axis is representing displacement and x-axis is representing time, then the slope will represent what? Velocity. Huh? So at 2 points of time, if the particle is having the same velocity, I mean, if the graph is having the same slope, that means the velocity will be same.
So,
yeah.
Like the slope of both the cos 120 degree and 270 degrees are same just because they were parallel, right?
120 and this thing, 240.
Yeah, sorry, sir. That's 240 degree.
Yeah.
Just because they were parallel.
Yeah. How do we know that they are parallel? Because the slope is minus half for both of them.
Then, sir, for the slope for 30 degree and 330 degree won't be same.
No, they will be parallel. Correct. 30 and 330 will also be parallel. Like similarly, 60 and 300 will also be parallel. So see this slope. This will come out to be how much? Slope at 300 degrees will be nothing but cos 300. So that is positive of cos. Sorry, 330. My mistake. So that will be cos 30.
Yes, sir.
So that's again root 3 by 2. So these two are parallel. So this is having a slope of root 3 by 2.
Okay, sir. Thank you, sir.
Yeah.
So, sir, at value of sine 60, the slope obtained will be negative of the slope at sine 120, right?
Yeah, yeah. For the sine graph, the slope at 60 will be negative of the slope at 120. Like that, the slope at 30 is negative of the slope at 150, which we haven't drawn here, but
Yes, sir.
So there are those symmetries which are working out. So like, there are multiple symmetries. Like if you look at the graph from 0 to 90, and then the remaining part from 90 to 180. So it's like this is a mirror, and there's an image on either side. So a slope here is equal to a slope here. A value here is equal to this. These slopes are negative of each other, but the y coordinates are same. Okay. Then if you look at the value from 90 to 180, and then 180 to 270. So it's like a inverted mirror image. It's like you've taken a mirror image and then inverted it. So that's why the slope at this point and the slope at this point are same. But this time the values are opposite. If this is some plus half, then this will be minus half. Okay. And then again from 270 to 360, you again have a mirror image symmetry with respect to 180 to 270. Okay, so that is the symmetry aspect of the sine and cos graphs, right? Okay, so these examples are clear now, people.
Yes,
So let's
sir.
do a, yeah. So let's do a quick exercise of some problems. Okay. So find dy by dx, okay, and the slope of the tangent at x equal to pi by 4 and x equal to 5 pi by 4 for so just try this out. Now you know all the formulae we've discussed about for this. Okay. Yeah, sorry people, there was some issue with the mic at my end. Yeah, so to answer your questions, differentiation of cos x is minus sin x. Okay, that is a part of the formula that we have learned earlier. So these two formulae we have to always remember. Differentiation of sine is cos and differentiation of cos is minus sine. Just like we know the formula that differentiation of x to the power n is what it is, nx to the power n minus 1. So like we use this as a direct formula. So like that we have to use these two as a formula. Okay, and then we also know the properties of differentiation, that constant into a function becomes constant into differentiation of the function. Okay, and so on and so forth. We have so many properties. So all that we have to apply over. Okay. So understood now how that differentiation of cos x is minus sin x came. Yeah. Okay.
Yes,
So
sir.
Yes,
okay,
sir.
so now see here what property we'll use to get from here to here. We'll use the property that differentiation of one function plus another function is what? Differentiation of first function separately added to differentiation of second function. Is like the distributive property. So that will apply to this function over here. Okay. So for example, if I had differentiation of x cube plus x square, how we used to do this? So differentiate x cube and then add it with the differentiation of x square. So that becomes 3x square plus 2x like that. So same thing will apply over here. So this differentiation of sine plus cos will become differentiation of sine separately plus differentiation of cos. Now we go back to the formula. So differentiation of sine is cos, but differentiation of cos is minus sine. So what is the derivative of our function now? The derivative of our function is this thing. So for this function, the derivative is this. This is
Sir,
the
can
function.
you show the up which you did, which you explained this one?
This thing with this, no?
Sir, up you explained the how of that
वो तो
formula.
formula था ना बेटा, sin x का derivative cos x है और cos x का derivative minus sin x है. This same thing, na? This formula. Where we written down that formula. I just reference that formula.
Sir, you went to up.
This and this formula.
Okay, sir.
Okay. Okay, so now, so I've got the derivative of this function. Now, next what I want to do, I want to find the slope of tangent. At which point? At pi by 4, x equal to pi by 4. So that will become how much? Cos pi by 4 minus sin pi by 4. Okay, so that's basically how much? 1 by root 2 minus 1 by root 2, so it's 0. So many of you got the answer correctly and send me on the text. That's correct. Okay. Now same way, the slope of tangent at x equal to 5 pi by 4. So 5 pi by 4 is basically how much? It is 225 degrees. Okay. So it is 180 plus 45. Or you can say it is pi plus pi by 4. Okay. So as we have seen earlier, cos of 5 pi by 4 is minus cos pi by 4. It's minus 1 by root 2. And so is sine of 5 pi by 4. That's also minus 1 by 2. So sine and cos are both negative in the third quadrant. This is third quadrant. So this will become cos of 5 pi by 4 minus of sine 5 pi by 4. So this time this cos 5 pi by 4 is minus 1 by root 2. But so is sine 5 pi by 4. So again the value is 0. So both the slopes are coming out 0 for this part. Okay, so this is clear now?
Yes, sir.
Yes, sir.
Very good.
Yes,
Sir,
sir.
sine will be pi upon 4. No?
Sorry, beta, what was that again?
Sir, down में sine will be pi upon 4. No?
5 pi by 4.
5 pi by 4 for cos and for sine pi upon 4.
Uh, sine 5 pi by 4 is minus sine pi by 4, which is again minus 1 by root 2. No, that's how we got this. Got it now?
Yes, sir.
Sine of 5 pi by 4, there's one step in between. It's minus of sine pi by 4. No? So this is in third quadrant.
Yes, sir.
Sorry, minus of sine pi by 4. Okay. But that pi by 4 is that unique value, no? Where sine and cos are the same.
Yes,
So that's how it finally comes out. Okay, my software is again hanging. Just a second. Yeah. So this is minus sine pi by 4. So for any other value, these two would not have been the same, but because it's pi by 4, so they are both equal to minus 1 by root. So that's how we have.
That's
we are
why.
getting
Okay. Thank you.
Okay, so with this now, I think you should not have any difficulty with differentiation of the trigonometric type of functions. Okay, so we completed this part. Next time we will look at another important technique in differentiation, which is called the chain rule, and with that we will complete differentiation, so that then gradually we can move on towards integral calculus and the last part of calculus. Okay, so that's it for today's session, people. I will send you a list of questions to do from the module exercise now, and also some practice questions. You can try that out for the next class.
Sir, these notes you will send, no?
Yes, notes and video I will send to well. Okay, along with that I'll send an assignment also this time. Okay, so thanks for attending, and that's it for today, people. Have a nice day.
Thank you,
Thank
sir.
you,
Bye.
sir. Have a good evening.
Bye, sir.
Yes, good evening, people.
Bye, sir.